Okay, so thus far we've looked at pretty much everything up to a year, and here in the instructions, I give you a second part, and yes, I say for the second part we will use our results from the first part and take costs into consideration and compare the current and the 3 replacement machines. So just to take you back to the data, so we have that results for the whole sizes, but we also have price information for the different machines. And here above, we also have additional information where I say that the new machines all have a lifetime of 365 days, after which they have to be scrapped, and we're not getting any money when we scrape them. And in our manufacturing line, the machine has to drill holes for 9 hours a day, and it takes 3 minutes to drill a hole. So when a part does not meet specifications, the client is reimbursed. So that costs us about 100 Rand for the defective product. Okay, so this is all new information. We now need to use this information to sort of get to a true cost of each one of those machines. So we've now looked at the machine part in industrial engineering. Now we're going to have to look at the money part and see if we can get a balance there. Okay, so I'm not going to show you exactly how to do it. I'm just going to give you some hints, and the rest I'll leave to you guys to figure out. Okay, so first thing, we probably want to just look at that new data that we have. So we have our machine or our current machine prices. There we have machine holes prices. So let's say my prices is equal to read CSV. Okay, let's press that and say, okay, it's that one. So let's see what my prices look like. So go to my prices, we'll see we just have 3 variables, and it gives us the price for each one machine, and it gives us in this very not so nice mathematical way of displaying it. So it's 1, 2 times 10 to the power of 5. So that's 100,000 Rand, that's 80,000 Rand, and that's 90,000 Rand. Okay, so that's our prices. Now the next thing we need to do is we need to figure out if we use a particular machine. How much is that machine going to cost us in terms of defective product returns? Okay, so this is where we're going to have to piggyback on these values. So over here we calculated the percentage of products that are defective. So what we can do is we can actually calculate the total number of products that we need to manufacture over a year, and then we can calculate the number of those products that will be defective, and then multiply that with our defective rate. Okay, so I'm going to help you off here. So we want the total number of parts that we need to actually manufacture. That's the total number of holes, so total holes. And that is equal to, that is all given in the data sheet. So we said this machine has to work for 365 days a year. I'm going to start with that. So it's 365 days per year times how many? And then we say it takes 3 minutes to drill a hole. So it's for 9 hours a day, so it's 365 days per year times 9 hours times 60 minutes. So that's the total available time that this machine will operate. And it takes 3 minutes to drill a single hole. So our total holes that we will drill in a year is 365 days times 9 hours times 60 minutes per hour, and divided by 3 minutes per hole. So this is the total number of holes that we have to drill. So total number of holes is 65,700. Okay, so all we need to do now is we need to multiply that by the sort of defect rate of machine to figure out how many of those holes are not going to be according to specification. And then we just need to multiply that by the cost of how much it costs per hole. Okay, so I'm just going to use one example. So with the current machine, we know it's 0.63. So our defect rate cost with our current machine is going to be that times 0.63 times 100 Rand per defective hole. So that machine is going to cost us about 4.1 million Rand in defective products. So that's how much it's going to cost us to keep the current machine. If we want to see how much machine 1 is going to take us, so again, that's going to be the total holes times 0.03 times 100. And the other thing now is we actually need to add the price of that machine. So that comes with our my price data. So that is 1 times e to the power of 5, which is 100,000. So now we just need to add 100,000. So let's execute that. And we'll see that machine will cost us 297,100 Rand. Okay, so we can stick with machine 1 for another year, and it will cost us about 4 million Rand. Or we can buy a new machine for 100,000 Rand, and then the total cost will be 297,000 Rand. So there's quite a big saving between those two. Okay, so I'll leave it up to you to analyze the rest of the machines and then to make a final recommendation. If you want, I'll encourage you to do this, is to try and sort of make it a little bit more elegant. See how you can actually use that previous stuff directly. So what we can do is in our previous file, when we have this table over here, we can actually assign that to something. So let's make this my prop table. Table is equal to that. And now it's saved. So now we can call those values directly when we're using this stuff. Okay, so play around with this and then calculate the total price per machine. And then see if you can make a recommendation in terms of which machine is actually going to be the cheapest one for the rest of the year.